Please settle down. We're about to start the session.
Okay, good morning everyone. Welcome back to second day of Episteme 10. I hope you had all a very productive and engaging discussions yesterday. And let us continue such discussions today with a first talk by Professor Savita Ladage. It's my pleasure to introduce her. Professor Ladage is currently the Dean of HBCSE. She obtained her PhD in chemistry education from the same center, working in the same center. In fact, she has been associated with HBCSE since 1987, initially as a PhD student and later continuing her career as a faculty member. And Professor Ladage's primary research interests include chemistry lab education, particularly at undergraduate undergraduate level, and conceptual pitfalls in chemistry. Our contributions include several pedagogical articles, book chapters, books, and also research articles published both in national and international peer-reviewed journals. She is currently a member of editorial advisory board for Journal of Chemical Education, which is an ACS, American Chemical Society's publication. She's also served as a member of International Steering Committee for International Chemistry Olympiads on several occasions. At HBCSE, she has been instrumental in two major programs, that is Indian National Chemistry Olympiad, INCHO, which leads to the selection of Indian team for International Chemistry Olympiad, and also the another program, National Initiative on Undergraduate Science, NIS program in chemistry, which organizes exposure enrichment camps for students, and also capacity building programs for chemistry teachers teaching at UG level. For her contributions to the field of chemistry education, she was recognized and awarded with the prestigious NIHOMS Prize for Education from the Royal Society of Chemistry, United Kingdom, in the year 2023. With this brief introduction, I invite Professor Ladage to deliver a talk, which is titled as Chemistry Education Research Based Capacity Building Programs for Chemistry Teachers at UG level. Over to you, ma'am.
Thank you. So thanks, Satish. Thanks for that introduction. And before I start with my talk, I'm able to see alumina member here. I can see GN. Okay. I can see Sugra. Sugra is very much there. Where is she? Yeah, very much. Swapna also is there. And I can also see some of the teachers whom we interact have joined today. So thanks for coming. And I start with my talk. So basically, Satish has already mentioned the topic about which I'm going to, going to talk to you for next 45 minutes. The rough outline of my talk is going to be, I'm going to first give you a few facts which you may be aware, but just for benefit of audience, and which is important background information in context of what I'm talking today. That will be followed by the discipline chemistry to which I belong and associated learning difficulties. And ultimately, I'll be talking about the capacity building programs which we have tried, our own conception, implementation, and our own learnings actually. UG stands for undergraduate phase of education. That's just an explanation. So let me now come to some important facts in the context of this talk. See, in last one decade, the undergraduate scenario, science education scenario within the country is changing. And there are few changes which are very important. So one of the first change which is important is that many colleges, and particularly state colleges which are affiliated to university system, today have a kind of academic autonomy, which gives them a freedom, to innovate with their own curriculum. That's one of the very important thing which has happened in last decade, and the process is still on. Along with that, since 2015, there are national efforts which were done to basically introduce teachers who are teaching at the UG phase with the pedagogical dimension, okay? And that has really, opened up this group of teachers towards the pedagogical dimension. Third important thing is that there are established, institutions in the higher education segment which are now venturing into capacity building program. especially for UG. And all of us are aware that the new national education policy, there are many things there, but the one which I want to say is that it has emphasis, or it is saying that the whatever education you will impart at UG level, it needs to be student-centered. So, since the teacher community, the science education, I mean those who are teaching sciences at UG level have kind of gone through these experiences, today they are much more receptive towards the pedagogical dimension. See, what you need to cognize is otherwise the teachers who are entering in the UG phase do not come with a kind of a pedagogical degree like B.Ed or M.Ed, that kind of a thing, and generally often do not have experiences with the pedagogical dimension. And these efforts, particularly the PMM's Pandit Madan Mohan Malviya scheme, has really helped to open them up with respect to the pedagogical dimension. So the stand which I am taking is that this is perhaps the right time where we need to venture into chemistry education research based capacity building programs for the UG teacher, and the sheer reason for that is that this is a kind of a less explored space, okay, and in general term it can be said as a D-bar inform. D stands for discipline, in my case it's chemistry, but you can have biology, physics, astronomy. So that's the point which I am making, that is the right time that we should venture into this area, and we require models. In Indian context, we require models for this, and that is where we have ventured, we have done some efforts. So let me now come to the chemistry and associated learning difficulties. And what I am going to do is that I am going to look at this from three different perspectives. One is that nature of concepts, the second is problem solving, and the third is lab education. Now, why I am discussing the nature of concepts, okay? So personally, I believe when you are in the realm of discipline informed kind of capacity, the discipline is very central to any conceptions of capacity building programs of this kind, okay? And especially the designers who are venturing into this field need to really familiarize themselves with the concepts, and the kind of challenges they bring, because ultimately you want to change, the understanding. That's the primary goal why you are doing your capacity building program, okay? So whether you deal with this, often you will be dealing with this area perhaps indirectly, which is absolutely must that we familiarize ourselves with the concepts and the problems associated with it. And that's the reason why I'm going to spend some time, and then I'll move on to other areas. So I'm going to draw very heavily from a researcher, Keith Tabor, and those who are familiar with the chemistry education research field, they know he's one of the very well-known and well-established researcher in the field. And he has given a very nice discussion about, the concepts, their nature, and how you should go about it. I mean, it's a very beautiful book. Who are interested can read that book. And he has given what kind of concepts, what kind of categories of concepts which are important when it comes to chemistry. So there are concepts related to objects, entities. I have given examples there. I think they are self-explanatory. Then you have concepts related to events and processes, and you also have concepts related to quantities or properties. Okay, so these are kind of categories of concepts which are important when you are teaching chemistry at any level. I mean, it is school or UG, whatever it is. Along with this, there is another important class of concepts which becomes important, and especially that becomes important at UG level, and that is meta concept. What he has called this as meta concepts. Meta concepts is something which refers to models or theories or laws, basically dealing with the various concepts. I mean, there are meta concepts which connect different concepts, and also meta concepts are used basically to provide explanations in the discipline as well as to do predictions. Okay, so this is another important, and at UG level the density of meta concept is quite high. Okay, and we have to reflect very deeply about whichever area you want to take for discussion. One should really do this kind of a synthesis, what kind of a concepts which we are dealing with and what kind of meta concepts which we are dealing with. Okay, now when you say something like model, please also cognize that for a given concept, and I have given example there that of acid, because most of you will be familiar with it. For any given concepts, often there will be multiple models. Okay, And the reason why I'm saying is that all those multiple models are introduced to the learner, okay, as they study chemistry from school to UG. So perhaps the very first model in case of acid which gets introduced to the student is the Arrhenius one, and that is followed by Bronsted-Lowry, and that is followed by Lewis, okay. It's equally important to cognize that these models, some of these models have their genesis in experimental observation. So for example, Arrhenius model, okay, this has like emerged from the experimental observations, okay. So some of the models have their genesis from the experimental observation, whereas if you consider something like ideal gas law, okay, that kind of a thing is a theoretical construct. So you have models of two kinds, one which have emerged from the experimental observation and one which are theoretical construct, okay. In chemistry, models or model based I will say reasoning or generally the models are used for visualization and as well as for reasoning, and this is used both at descriptive. What I mean by descriptive, something which you can feel, sense, for which you have perceptible experiences, okay. So the models are used both at the descriptive level and as well as the submicro. Submicro refers to particulate model of matter, which is a very powerful explanatory framework which is used in chemistry, okay. So models are used at both level. It is not just the submicro level where the models are being used. Now when it comes to the capacity building program, it's important that we have to think, and this is more towards the designers, okay, that what kind of a teaching experience we need to present to the teachers, okay, which will help them to understand concept related learning difficulties. Now this is a very deep synthesis, and unless we do this kind of a synthesis, I'm not sure whether we will be able to do, we will be able to conceptualize a CBP, which is a kind of a good in the sense is presenting what it is supposed to present. Now let me now come to the other area, which is problems and problem solving, and I'm not going to focus my attention on numerical problems. I'm going to focus my attention on non-numerical problems, and Talankveer has given a very detailed discussions about it, whom you will be listening tomorrow, okay. So this is what I'm saying is kind of drawn from his writings, okay. So let me focus on non-numerical problems, and non-numerical problems often requires qualitative reasoning, okay. This is very different from the numerical problem, and qualitative, when you are in the realm of qualitative reasoning, you need to work with symbolic representations which are used in the domain, and they are used basically to communicate information about the structure of the components and the composition of the components, and we need to decipher. Anyone who studies chemistry need to decipher this particular thing, and when you are deciphering, you are actually connecting structure to the property. You are looking at those linkages. Not only that, you are also, you need to interconnect that structure property relation to the behavior. I mean, a system is often complex. There will be n components, okay, and these n components are affecting each other, and each component has its structure, it has its own properties, but in the environment it will behave in a certain way, okay. So it's very important that you link the structure to the property to behavior, okay, and this is large extent not done in our conventional teaching, and we need to pay attention. Now let us understand this, dealing with symbolic representation point more in detail, and for that I have taken a very simple example. All these symbols which are shown there represent water, okay, and if you look at this symbol, okay, you will agree with me that just looking at the symbol you will be able to see some information which is called as visible information or explicit information, and there are, I mean, examples given. So you will be able to say ki which kind of atom is present, okay, type of bonds probably you will be able to say, and connectivity, okay. The other important aspect is that there is some implicit information or not visible information, and again I have given examples that when you have to give explanations, you also have to worry about implicit information, okay. So something like atomic size, number of valence electron, electronegativity, and so on and so forth, okay. Now for explanations in chemistry, you need to decipher the visible or explicit information as well as implicit information, and you need to understand the interplay of this to come to the explain, and this process is not easy. Okay, I said that qualitative reasoning becomes important in non-numerical problems, and let us see another scenario where the qualitative reasoning becomes even more important. So that brings me to the context problems or real world problems, and also let us take a research situation at this juncture, and again you will agree to me that when we say real world problem or research scenarios, they are dealing with complex reality, I mean the situations in the real life. Okay, and often these situations are messy situations. They are not like, textbook well defined situation where you know the starting point, kind of you know where you are reaching and the path to reach it. Okay, those kind of problems in literature, in the science education literature, are called as well defined problem, whereas the problems where these trajectories are not known, starting point may be known little bit but the end is surely not known, those are ill defined situations. And when you have such a situation at hand, the way to start thinking is qualitative reasoning. Okay, you have to start attacking the problem or start thinking or reflecting on the problem from the realm of qualitative reasoning. So when you talk about context problem, qualitative reasoning again become very important, and this is even important, and those who are familiar with the chemistry education research literature, there is a very powerful notion which is emerging and which is going to take center stage in the years to come in chemistry education. We cannot ignore this particular idea, that teach chemistry with system thinking approach. Okay, so what you are able, this figure is trying to represent, it represents a tetrad, and basically the bottom of this, okay, indicates the three different major components of chemistry, modern chemistry, which we teach in the school. This is proposed by Alex Johnston, who was another pioneering CER researcher in the field. So there is a descriptive part of the dimension to teaching chemistry, there is a sub-micro dimension of teaching chemistry, and there is a symbolic dimension of teaching chemistry. But what is important is that we need to teach chemistry in context and in context to humans, because if you want them to take informed decisions, it's so very important that you teach chemistry with its complexity and its connectivity to the to human activities or whatever where the humans are involved. Okay, so what it means is that you present chemistry with its complexity to the learners rather than kind of presenting only this perspective which is kind of a filtered, I mean I'm just saying it to understand. So basically a filtered approach, and this is going to be very crucial, and my personal feeling is this is very important idea even in India in context of NEP. If the kind of shifts the chemistry courses have to make is pay attention to system thinking. Okay, so here again the qualitative thinking and the context problems become important. So it goes without saying that if you are in the realm of CBP, it's good to think about this area, and perhaps you may want to venture into it. That brings me to the lab education, and in CER literature what has been critically looked at is the learning in the conventional lab. See, when I say this, I mean often please don't look at conventional lab education in a derogatory way. It is still an economical way to do things actually, and it achieves many things. Okay, but what has been critically looked at is the learning. Okay, and let us consider a chemistry lab situation which is like must be there for biology or must be there for physics also. Okay, so look at the learner. The learner is receiving various inputs. Okay, there is a theory, okay, which may be coming verbal or written form. There are chemicals, instruments, okay, glasswares, okay, the operations to be performed. All this is happening in that 2.5 hour or 2 hours or 3 hours period. Okay, now this has been contested, and contested from cognitive load theory perspective. So what is the argument? The argument is that the working memory of the learner, which is equivalent to, analogically it is equivalent to RAM of the computer. This term has come from information processing theory basically, but this is a RAM of the computer. If this RAM is filled with too much of information, okay, then there is no space available for processing, okay, because information is kind of occupying that space, and if you want students or learners to reflect, it's very difficult because there is no space. In other words, it's putting a load on the cognitive load on students, and this situation and this scenario needs to be considered, and there is a very important notion which has emerged from this, which I will be talking about. Now there is a lot of work done about lab, and I'm not going to touch upon various things, but I'm going to go to another influential researcher, and perhaps some people may be aware of him. He is Michael Seri, okay, who has done significant amount of work when it comes to learning or chemistry lab education, particularly at UG level, okay. So one of the fundamental questions Seri has tried to ask and also answered is what is so different about learning in the chemistry lab, and he's asking this question as against theory, okay. And he chooses a term, which is a term by educational psychologists, okay, that lab is a complex learning environment, and by complex learning environment he is explaining what he means by that. He says the learner has to engage with the process of integrations of different components. Now these different components can be skills, operations or theory or explanation, those are different components, okay. But a learner needs to integrate the necessary components and get to, and apply it to the situation which is at hand. And this process of integration is not easy for learners. And he takes a stand that this process of integration needs to be supported well, and I completely agree with that stand, that if you do not really support the process of integration here in his word, but just extrapolate this to your, capacity building program, if you want teachers to cognize, okay, what you are saying, you need to support it well, okay. There are enough scaffolds to be provided so that they get the idea, which is basically which you are trying to communicate, and that's very important. And this becomes important when you are developing the instructional materials which you are going to use for the capacity building programs for teachers. What he has done very nicely, and I really appreciate that, he looks at the learning prior to the learners entering to the lab, and he has given very good guiding questions. I'm not going to read those. Those who are interested can read the paper which is at the bottom, and these questions according to me are very important for any instructor, for any CBP designer. So he talks about learning. When you focus, you have to focus on learning prior to the students entering the actual doing of the lab, okay. And these are some of the questions which he has mentioned. Then he talks about questions which are when the students are doing things in the lab, okay. So he has given another series of questions which are very important and which acts as a good starting point, okay, to reflect for us and to think deeply about when you are designing any kind of a lab activity, or if you want to venture into chemistry lab education, CBP, okay. So he talks about learning in the lab, and then he talks about learning post lab, after the lab, okay. So there are questions which are given, and these are very, again I again and again repeat that these are very important, good starting points. Our work had started before 2019, but when this paper came, it has helped us tremendously, to reflect on things which we are doing. So Seri talks about this, and of course it goes without saying that CBP, the chemistry lab is yet another domain for CBP, okay, at the UG level. So that brings me to our work, which is the work done by the Chemistry Education Group, which is located at HBCSE, and that's a website where you can go and read about our work. We have collated various things at that website. It will be nice that if you will visit the website, okay. So which are the areas which we have ventured into, okay. So we have ventured into chemistry lab education, that's one of the important area. And why we picked up that area? Because I think all of us come or connected to teaching learning profession, and this is one area which is less innovated when it comes to curriculum revisions and all that. And that is why we decided that we will venture into this area. So that's the prime reason. Okay. The other thing which we have ventured is problem and problem solving, which has this emphasis on context problem. That's one part. But apart from that, we have also introduced teachers to what is called as guided inquiry learning approach, and particularly the material which has been designed or developed using this approach. So under problem solving, we have two different categories about which we interact with the teacher. When it comes to assessment, assessment is a huge area, and there is an absolute need to have CBP related to assessment, but we have not ventured into it as a separate domain. Rather than that, we deal with assessmental kind of aspects when we are discussing experiments or context problems. Okay? Our work has been done at the UG level as well as for the teachers who teach at what is called as higher secondary or class 11th and 12th. But as far as this talk is concerned, I'm going to focus my attention only for the UG, our efforts which are done at the UG level. Okay? So before I tell you what we really do about labs, let us once again reflect on the system. Okay? So in India, you currently have BSc courses and you have kind of integrated MSc or BSMS courses. Okay? The BSc courses currently are 3-year courses, which with NEP are likely going to be 4-year courses, okay, which are like currently under transition. Okay? And if you look at, there are differences between these two kind of a system. So when it comes to faculty, okay, there is a difference in the faculty which are teaching in the BSc courses. They are generally not engaged with high-end research domain. Okay? Whereas if you look at the faculty which are teaching in BSMS courses, they are often kind of engaged with the advanced research areas. Okay? The BSc kind of a, the college system where the BSc courses are implemented is a very massive, national, gigantic system, and it comes with a lot of diversity. Okay? And one of the point is, that is why this issue becomes how we should structure things so that we have assurance that things do work or things do happen in such a massive system with a diversity. Okay? That's an important question. In the BSMS system, projects is already an integral part of your education, and 5th year is a completely project. And what I understand through my interactions with teacher, that with NEP there is an expectation that when BSc courses will become 4-year courses, even they are supposed to offer projects. Okay? So that brings us the next set of questions which we have been deliberating throughout our conception, implementation, and we keep revisiting. So now some of the questions related to system, what we have kind of tried to understand is that in what way really the lab courses are innovated. And please understand, it's very easy for us to say innovate, okay? But there are ground realities, all right? And one of the ground reality, the most important thing is the infrastructure and the finance, the budgets which are available. And that becomes an important constraint when it comes to innovations to the lab curriculum, okay? This need to be cognized, okay? Then what are the content areas? Of course, what is the dominant instructional practice that has been followed? And I just want to put this question to the audience here. In the BSMS system, what is the purpose of offering project? What is that we want to achieve? Okay? And again, through interactions or the way I have understood it, and I'm very happy to hear the counter arguments, is that the purpose is that you want to really, engage students with research domains. Okay? You want to enculture them into the research domain. That's the main purpose. And how do you go about it? Often there are interaction with senior PhD students, initially. There's an apprenticeship model there. You set your hands, you understand. Then there is an intuitive knowledge which you try building up by hands-on experiences. But ultimate goal is to enculture students into research domain. Okay? Now the question is, when we want this to happen in regular system, okay, where we do not have research facilities, okay, where the faculty is not involved with the research domains, is this purpose the same or achievable? That's achievable. That's the kind of thing which I'm I'm going to leave that there, and are there any alternatives, okay? And even people, I mean including me, okay, who are designing the project, what is our own conception about project, okay? What is that we value, or what is that we want to, do we critically reflect on the way we design the projects, okay? So that's equally important, and these are kind of questions which get discussed within the group and again from time to time when we are designing and implementing the CBPs, okay? The other important questions which we have worried about is what are the CER ideas which we want to take, okay, take to the system, okay? If we select certain ideas, how do we really structure our CBP? What kind of instructional material we need to develop about it, okay? And what kind of content areas we need to select. All this in a context of chemistry lab, okay? And of course, we have come a long way. This is more than a decade we have been implementing these kind of courses. We are still evolving. It's because, the system realities are changing, and you should be open to those realities, and you should fine tune your CBPs, okay? You cannot say, this model which worked today will work tomorrow also, when the ground realities in the system are changing. So what are the kind of ideas which we have picked up? So one of the most important idea which we have picked up is introducing teachers to pre-lab, lab and post-lab concept, which this particular idea has come up from cognitive load theory perspective, and which is a very powerful idea and very much implementable in the Indian context, okay? Of course, the CR literature also tells us that we should introduce inquiry-based approaches for the labs, but what we have done, we have taken a stand that when we are introducing inquiry, it needs to be introduced slowly, okay? So we have not gone to the higher levels of inquiry, like open or authentic inquiries, but rather than that, we have restricted ourselves to what is called a structured inquiry or guided inquiry, which is lower level, which involves, which is kind of termed as lower levels of inquiry. And the sheer reason for that, ultimately we want teachers to make shift, okay? And making shift in incremental manner is perhaps a better trajectory. That's our hypothesis or conjecture, and that is why we have kind of restricted to the lower levels of inquiry. Of course, we are also thought about some alternatives, and this word investigatory project is, I'll be explaining this in some time, but we have tried to develop these kind of projects which are actually revolved around the experimental methods which are integral part of the UG syllabus, okay? So in terms of domain, we are not going to high-end domains, okay? However, students do not have an idea how the current knowledge or how the current methods which they are dealing, how they have been arrived at, how this knowledge really we reach to this stage. So what we are doing is that we are opening up this established knowledge, and we are designing projects, around that, okay? In a way, I will use what Gohard had said. We are kind of making a shift from research informed to research like, okay? So basically, what they know is the knowledge which is generated by the research done years back, but we are kind of creating research like situations, basically, which is like mimicking the research thing, and we are building projects about that and concepts about it, okay? There is another thing which is from the literature, which is mini project mode. Now this is a little different concept. What you do is that you give everything what is going to be available to the student in the lab. So you give the list of chemical, glassware, instrument. There is no flexibility with respect to that, okay? But you don't give procedural details, kind of, okay? And they have been asked to design the procedure. So it is giving a planning opportunity, but in a very restricted, limited sense, okay? And you can adopt this idea even as a part of your course. So if you do 3 titrations acid-base kind of a thing, you take the 4th one and convert it into mini project, which is like 2 lab periods, max to max 3. You don't require 3, you require only 2, okay? But what you are doing that within the curriculum or within the lab, you are creating a situation or a scenario where students are going to use what they learn and kind of revisit it, okay, which will help them to consolidate or to understand what they learn in a better way. So that's the notion. Of course, learning needs to be supported, and this we have paid attention when we are developing our own materials. And still in Indian context, lab is not a group work, so that's another important thing. I mean, the teachers also do their work as a group, as a pair, okay, in our camps. So when it comes to our instructional materials, one of the things which distinguishes it from perhaps from other, but it's characteristic of our work actually. Whenever we develop anything, we have always field tested it with the UG student, and we have this National Initiative on Undergraduate Science Camp for Chemistry, and there we test these modules. Whenever time permits or opportunities come, we take it to regular colleges also. But it's kind of test, this is an integral feature of our NIUS camp. Experiments, they are selected closer to what is there in the syllabus. Not exactly, it can be exactly from the syllabus or closer to what is the thing. And so what happens is that classroom data is very much available, the problems, the difficulties that are going to be faced by the students are very much known to us, and we take this to the teacher camp. And please understand, teachers perform these experiments by hand in the when the camps are on. Okay, we conduct these camps at HBCSE and most importantly outside HBCSE in regular colleges. Okay, towards pedagogy, there are pedagogical reflective sessions about design, decision making, the likely difficulties and likely challenges which will be faced. So these are the things. These are some of the photographs, and the one which is, this is our lab, but this is outside, and you can see that teachers are engaged in doing the discussions. This is a feedback. And what have been our learnings? Okay, so basically pre-lab, post-lab is certainly a format which is appreciated. When it comes to experiment modification with the actual lab experiment is more appreciated by teachers rather than the new experiment. Investigative project is a challenging idea for teachers, but they like it very much. Okay, for teachers, see, there is so much delinking between observations in the lab, okay, and the theory. I mean, even physically we have segregated them, but that is why looking critically, observing things in the lab, and you develop or you advance your argument based on this observation. This is something very difficult. I mean, one of the difficult areas for teachers. There are of course conceptual difficulties, and when it comes to design, okay, designing the purpose of pre-lab question is something we have to deliberate considerably with the teachers, and often there is a tendency to design post-lab questions which are theoretical in nature rather than relating or connecting it to the experiment which they have performed. So that is another problem. Let me now narrate one of the collaboration which we did with teachers, and please note down the duration, it's 2.5 years, and we wanted to see whether we can interact with teachers and really design lab experiment with pre and post lab thing, and all details are there, but let us see how did we proceed, okay, how did we go about it actually. Okay, so what we did was that we invited the teachers to participate in our NIUS camps, and they initially witnessed when HBCSE people were implementing these modules, and then they were given opportunities to implement. Okay, so basically it really helped them to get experiences about process of implementation, and they also witnessed what happened to at the students' end. This really helped them to build their confidence. And most importantly, after some time gap, we started something called as online study circle. Okay, this is a weekly study circle which happens, and the purpose of this still goes on, but at that juncture the area which was picked up is the literature related to lab education. Okay, and those kind of papers were discussed and deliberated along with the example where things have been really implemented. So that and these teachers were attending, all these 10 teachers were, they did not miss a single session of those kind. Okay, then of course after 2 months the idea of writing the experiment was floated, and they were very much willing, and the choice of experiment was left to them. So we did not intervene into that. Okay. This is now published as a book. Okay. And what is nice is that these teachers kind of followed the same process. When they develop, they also field tested it with the NIUS camps in the regular college, because some of the in-service teachers were there. So in their own setups, they did the things actually. And along with that, we also tried out these. We wanted to hear, how other teachers look at it. Okay, so they have been tried at CBP, both at HBCSE, and ISER Pune conducts such major activity, and we are thankful to them that they have allowed us to, test this in their thing. So that is how we have done. Anybody is interested, this book is very much available on Amazon. So what are the key takeaways? Okay. So key takeaways for us is, I'm not going to discuss the first one, but the trajectory, what appears works better is that you start with the kind of a content or, hands-on experiences, which is like a more a concrete dimension, okay? And then you start slowly taking them towards, reflective or pedagogical thing. That appears to be a better trajectory. We have tried various things, but this seemed to be working better when it comes to the teachers. Okay, of course, certainly the including teachers with CR literature, and since the study circle still continues, okay, it is at that juncture it has helped, and teachers have kind of now they read the paper rather than HBCSE members reading. So there is a distribution. Investigatory idea is very much appealing to the people, but I think what we need to do is that to understand this idea, how to really convert things into project. Okay, it's important that we collaborate with teacher, we sit with them, we take up an idea, convert it into project. Okay, have reflection, and that dimension we have not yet done, but there is a need to do that, which will kind of give, again, will help to build their confidence. That's what all these are our key takeaways. So now I come to problem and problem solving, and again I'm going to reflect bit on the chemistry education in Indian context. If you look at the chemistry education from school to UG level, you will agree with me that in the syllabus very early the abstract concepts are introduced, like concept of atom and all that is being introduced. We have not given opportunities to students to deal with materials, to understand them, differences and all those patterns, but very soon we introduce this model. Okay, so abstract concepts are introduced very early in the syllabus, class 8 or something like that, and our syllabus is kind of a spiral syllabus. So you go on expanding this, okay, when you are going from school to UG level. Okay, unfortunately in this journey there is, at least I have not seen the situation where there are efforts being made to relate this to real world. Okay, so what happens is that we are kind of working in isolation. We are having a conceptual trajectory, but how does really works in the real situation is something completely dealing, and that's why I'm making a statement that context problems is not an integral part of chemistry education in India. I'm not very well versed about what happens in IITs, but some input says probably there also. Maybe it's not happening, but I don't know. I'm not the person who can say about it. Okay. Now, when we are venturing into what are our credentials, okay, why we are competent people or we are the people who can really venture into it. So please understand, HBCSE has another program, Chemistry Olympiad, which is very well known. But I think we should look at this program from an educational perspective rather than just considering it as a program which leads to the selection of the team. That's a separate mandate. Okay. But we have been designing context problems, and this is again deliberate stand which we have taken, okay, to indicate this lacuna. And one of the person whom you should meet is Ankush. He is Ankush Gupta, who really, please, okay. So you can have discussions with him, and it will be a pleasure to hear him when about this thing, okay. So again, how do we go? We again we take these problems which are quite, they are large thematic problem. This is not just one bit or two bit of a problem. There are a series of questions, those kind of problems we take. We have also chosen consciously to introduce areas which are less represented in such kind of problems or overall in designing of problems, that is qualitative thinking, visuospatial reasoning, taking real situations and analyzing them, or taking a real complex data and making meaning out of it, numerical calculation and along with all others. But this is a kind of a conscious choice of our group and extended family who interact with us actually. And the way we start again is that teachers start solving these problems. Okay, please look at our numbers and on the pedagogy side, we discuss about the context of the problem. We also have a considerable discussion about concepts which are involved. Okay, the likely wrong answers and reasons for that, difficulty level and overall design of the problem. Of course, teachers are very much invited to criticize it. It's not that it's an Olympiad problem, that doesn't mean it requires, I mean, it's an absolutely perfect problem, nothing of that part. And teachers can opine on that, okay. So very quick examples of this. I'm not sure whether you will be able to read it, but you have something called, there is alum, everybody knows, Turti, the one which is used at home also for purification of water. So there is an historical alum production. It's a very beautiful work and very meaningful if you read that, and which is also used as a mordant in dyeing. So this question is related to that. And then you have aquaculture, which has been developed at many places in India. And if the water quality there is a problem, then the whole aquaculture suffers. Those who want to look at this, please visit our Olympiad website. And there are quite a few significant number of examples there which are put in public domain. You can use it for your own teaching learning. If you want to get in touch with us, feel free to write to us. Okay. So that brings me to the other aspect with which we introduced this aspect to the teacher, which I told you about guided inquiry learning. The reason why this is a part of problem and problem solving is this is another way you do problem solving, or it involves basically problem based learning, and you give a kind of a context or a model is given to the learner to explore. Okay, and there are series of questions very carefully crafted, okay, which follows a learning cycle which is shown on the right. Okay, so initial questions are basically help you to explore, okay, which through this exploration you will kind of arrive, through self-directed learning you will arrive at the concept. Okay, you are kind of inventing a concept, and this is given as a group work, and then a new different situations are given to you. So whatever you learned you apply. So this is a concept consolidation. Okay, this is a very different approach, and this is something which we have tried out in our camp, and this is one quick example. Please visit this POGIL. If you type this, you will get all the details. This is one example. It's very carefully crafted material. Okay. Now I just come to another work which we have done, teachers, and please note down the duration, which is 4 years. That was 2.5 years, and this is 4 years. Okay, and where we wanted to develop guided inquiry learning kind of a based material with the teachers. And again, how did we proceed? This is a smaller group than the first group, and teachers were introduced to this. There was a conference held at HBCSE about chemistry education. International conference was held, and there where they came to know about this approach. Okay, but these teachers were a bit hesitant, and they were not sure whether they can use, and they were asked to get engaged with the real implementation of such material, and they tried it out, and this was in 3 different colleges, and they witnessed the issues and the challenges, but the whole thing was encouraging, and there where they decided to take up this work. Okay. Then of course there was a developmental phase where there was a sustained interaction, physical interactions with the teacher, and the preliminary drafts were prepared. Again, these drafts were field tested, and that is how the drafts were modified, and the work was hit by pandemic. Okay, and final drafts were arrived at through online discussion. Now this is also being published as a book, and you can have a look at it. But one of the major challenge which was faced by the teachers in this whole process is taking the role of facilitator. Okay, and this was very difficult for them. And for that, what was done was POGIL sessions were conducted at HBCSE, where one teacher used to teach and other used to sit and listen, and post this there used to be detailed discussion about the process of facilitation. Okay, And we had an expert, fortunately, who was visiting HBCSE at that juncture from USA, who is a Pogil expert. Okay, and you see this. So what are our learnings? So basically, one of the most important thing, what I want to say is that teachers do take time to differentiate between concept and information. And it is not their problem. These kind of discussions are not done with them. And it's important that we do this and we give enough time. That's one of the things which we have to understand. And teachers, even though they like the context problem, they're very unsure whether they can implement. And again, this happens, it's very natural that this happens because context problems are not integral to your syllabus or this thing. So there is no, one should not get surprised. Of course, the guided inquiry learning, and this is very much appreciated. I think we have yet not evolved with the problem and problem-based kind of that kind of a CBP, and perhaps it will be good to start with short context problems first. It is still a reductionist approach, but no problem, we can do that. I mean, the integrated has to be done, but just to get an idea, and better to choose problems related to qualitative reasoning, visuospatial reasoning, and interpreting the real situation. And it gives them enough time to understand the concepts and the difficulties associated with the concept, and that will help them and motivate them to take this to their labs. But of course, we have to come to the thematic one. So just to, I'm little late, but just to tell you what is my overall summary. So one of the main argument which I'm trying to build is that discipline is very central if you're calling something as DBER informed or DBER based CBP. Okay, you cannot ignore discipline, its structure when you're designing this kind of a CBP. Okay, equally important dimension is the pedagogical content knowledge, and within chemistry also you have to reflect very deeply how, when you're dealing with quantum and when you're dealing with stoichiometry or reaction mechanism, the PCK is going to be different and you need to reflect very deeply. Okay, there is a merit in conducting CBP related to lab in authentic colleges because it's more convincing. Teachers do see kids working in their own setups and they appreciate that. Okay, engaging teachers with CR is certainly advantageous, and whatever we have done till now, please understand they are short exposure models. Okay, we have not done something longitudinal. Okay, and this is the last slide where I leave for you. There is a need to have longitudinal models, okay, which will have thrust on implementation, because without sustained interaction, you cannot, I don't take this stand that there will be changes in the system, and neither our group members take that stand. The things which you have to worry about this kind of a CBP, you have to worry about content dimension, you have to worry about the pedagogical content dimension, and there is a general pedagogical dimension. So these three you need to really reflect on. How will you build this, okay, and how you will progress with all these three dimensions in the longitudinal, how much flexibility do you keep to fine tune your thing, all these questions become important. And last point is more important, in this whole journey, it's important to give ownership to the teachers, okay, and if possible action research. It may be too early for UG kind of a dimension, but that's why I put it as ownership. It's important to give ownership, because whatever said and done, when it comes to the CBP, it is always the top-down approach, which is the most dominant and which has a notion of knowledge transmission mode, okay, rather than participatory way of generating knowledge. That's the dominant perspective, and I leave you there. So these are my acknowledgements.
Okay, thanks for the wonderful talk, ma'am. But we have 5 minutes for taking questions. Yeah, please, Ataman.
Thank you for your lecture, ma'am. So,
please be seated and you can ask questions.
yes. So you already mentioned about the abstract concepts and the experimental thing. So we are also facing in training teachers in the abstract concepts and designing experiments. Even we are observing some cognitive dissonance and alternate conceptions among teachers. So how are you designing experiments for those concepts like mole concept, quantum chemistry, something
No,
like that?
we are not designing experiment for the concept. What you are doing is that you are taking a concept and designing activities or experiment for that concept. concept. We are not doing that. Okay.
Okay.
We are picked up the experiment which are part of the syllabus. Okay?
Oh, okay.
Then we synthesize what are the concepts, and then we talk about what kind of questions or this has to be this thing. So this is not a separate. The approach which you have said is a little different, and it's a very well-established approach in CR literature, which is designing experiments or experimental activities for conceptual enhancing. That's a separate approach.
Yeah.
This is a separate approach.
Yeah.
But
So you mentioned the triangle, Johnson triangle, right? So
Yeah.
so we have difficulties in touching the macro things.
Okay, I think we can discuss this
Yes.
thing with the actual examples. I think I'll be able to give you
Sure.
more input.
Thanks, thanks,
Surely we
thanks,
can
thanks.
discuss this.
Good morning. I'm Bhojraj, working with the Ministry of Education, Royal Government of Bhutan. In one of your slides, you have talked about bringing human element to chemistry education. So anything with human-centric approach to education, I always get interested. And then we are also coming up with Gelifu Mindfulness City, where education is going to revolve around a human-centric approach, actually. So can you tell us what is this human element? How do you bring that human element to chemistry education? Thank you, ma'am.
Yeah. So it's nice to hear that. I think what I will do is that I will pass on a website, which is a very good website, which is constructed by Mahaffey only, the person who has propagated this idea, and which gives you actual examples about how they have developed. And there is a commentary about that actually. I think going through that website and going through those examples will help you to plan activities in your thing, in your own because we have to pick up the context which is local context. We cannot pick up a context which is more familiar to students in Canada or UK or USA or something like that. We have to pick up, in your case, it has to be context in Bhutan which you have to pick up and design. But there is a website which really will help you, and I can have discussions about that. Okay?
Yeah.
That is-
This is a non-chemist take on what you. One of the points that was made, and it gets often discussed in school level or college level discussions, is about these various ways of looking at acids and bases.
Yeah.
The Arrhenius, Laurie Bronsted, and Lewis ways of looking at it. But what I often find is that it rarely gets discussed that these are three ways of looking at the same thing. I mean, it often seems like they're compartments.
Correct.
And this puts students in a very confused state where they think that there are three kinds of acids, or something like that.
No, I completely agree with Bhas. So one of the major, this you have said in context of chemistry, but let me tell you, this is one of the things, because what happens is that for a given system, there are always n possible explanations or n ways of looking at it, okay? And to the way I will put it, it's little different, but the way to understand or observe behavior, expert often makes a choice, okay? The model or the explanation which, that kind of a thing doesn't happen, or we do not give situations where students are given these opportunities to pick up, the models and the model-based reasoning, and to see why this is more better than other, that kind of a thing. And I agree with you that this is taught as absolutely separate things. They do not connect it. Why there was a need of other model, all those dimensions do not get discussed. That's absolutely.
So is there some way one can bring this in?
So there is I can again discuss, and I will tell you, there is I think if I remember correctly, there is a very nice paper on this. I think it's by Sybil Erudum, okay, which she has kind of developed particularly about acid and bases. I'll try to look for that paper, but I'll discuss with you, sure.
There's.
Thank you very much, ma'am, for your nice presentation. One question, what, in your opinion, is the possibility of incorporating sustainability, green chemistry, and lab safety in undergraduate teachers' education, which can then be followed up?
So basically, this idea of system thinking is very much related to green chemistry. If you go and see the IUPAC website, okay, you will be able to see green chemistry. All this is kind of linked to systems thinking. So system thinking is equally important and essential, okay, to teach concepts of green chemistry or sustainability kind of a thing. Okay, that is why I said that this is going to take a very center stage when it comes to chemistry education, and you must, in fact you should, even though it is like it will take time to percolate this idea, it's important to discuss these ideas with the UG teachers. That's the standard.
Yeah, we'll take, thanks
We'll-
ma'am.
yeah.
We'll take last question from Jam.
Acha, Jan,
Yeah.
acha.
It's a more global question related to science education. Is in these capability capability enhancement programs for teachers, what about assessment of lab work? Does that fit in as a specific category, and what does research have to say, and do you see it in relation to practices in our colleges? Because it's very different from theory, and both students and teachers know, and that also affects the way lab work gets done, and very often that has nothing to do with all the experimentation and all those at it. So how do you see that in this experience and research?
Yeah, I perfectly understand your question and your position, and there is a need. So in CR literature there is a work done about assessment, and particularly in the lab domain. Okay, there are templates developed. When people have talked about introducing inquiries and all that, how the lab report should be written, there are critical reflections on that, and one of the things which you may be aware about is science writing heuristics kind of a template. Okay, and there is another person, 1 minute, he's from Israel, who has also done a lot of work. I'll get the name, just kind of thing. So this is a kind of a research area in the thing, in the domain of science education. In fact, lot more work has been done in a context of biology also. Okay, where they have critically looked about the assessment methods which have to be adopted. There are protocols developed and all those things, and I think a bit we have touched upon bit in, there is a student who did a PhD with me, and she has worked on problem-based learning, but she touched upon this, lab, the lab report dimension in a limited sense. But in science education, there is work done about this. I think. Yeah, I will surely. I'll share that thing with you. Yeah, sure.
Okay. So thanks again, ma'am. Thanks for your detailed talk, detailing about nature of chemistry as a discipline, particularly particularly for teaching and learning process, and also giving insights on how chemistry education research informed capacity building programs are crucial for improving chemistry education in Indian context. With that, I'd like to thank. Please join me in thanking our. Okay, there is a break, tea break. You can have a tea just outside the auditorium. Be back at 10:55. Thank you.